This is the November 14, question 8b, part 1 paper. Now, first, deduce that carbon dioxide is covalent. This is because it consists of a non-metal and a non-metal, carbon and oxygen. The first question to ask is, what is the electronic configuration of carbon? Carbon has the electronic configuration of 2, 4. And oxygen has an electronic configuration of 2, 6. The second question to ask is, what is the number of electrons needed to become stable? Carbon needs to gain 4 more electrons, and oxygen needs to gain 2 more electrons. When you draw the dot and cross diagram, do not forget the valence electrons of oxygen which are not in the covalent bonds. So this is how the dot and cross diagram looks like. Carbon, oxygen, do not forget the valence electrons not in the covalent bond. First shell, 2 electrons. Four electrons being shared between carbon and oxygen. This is the dot and cross diagram of carbon dioxide. Next, for sodium oxide. First, deduce that sodium oxide is ionic. This is because sodium oxide is made from or consists of a metal and a non-metal, sodium and oxygen. First question to ask, the electronic configuration. What is the electronic configuration of sodium and oxygen? Sodium is 2, 8, 1, and oxygen is 2, 6. Next, what is the number of electrons needed to become stable? Sodium needs to lose 1 electron, and oxygen needs to gain 2 electrons. Remember that sodium loses an electron to become a positive ion, while oxygen gains electrons to become a negative ion. Do not get confused the charges of the 2 ions. So this is how it looks like. This is your sodium ion, positive charge. The oxide ion has 2 electrons transferred from sodium. This is the remaining sodium ion. So that is the electronic structure of sodium oxide. Now it is good to include the key for both dot and cross diagrams, so I'm going to write it here. And this is the completed dot and cross diagrams. Now for the second question, use these structures to explain why. Now when you see use these structures, I'm going to highlight the keywords here. Use these structures. You can see it here. Sodium oxide is ionic, and so it is made up of ions held together by strong ionic bonds. Whereas carbon dioxide is covalent, and so it is made up of molecules, not atoms, but molecules held together by weak forces of attraction between molecules. So when you talk about structure, these are the keywords that have to come out. If you talk about ionic, covalent, and you need to talk about the attraction between molecules for covalent. Now when you see the word explain here, it means you give the reason. Over here you see that sodium oxide is a solid. It's just another way of asking why it has a high melting point. The reason is because a lot of heat is required to overcome strong ionic bonds. And likewise for carbon dioxide, being a gas, it means that it has low melting and boiling points. This is because weak forces between molecules are easily overcome. So the answer would be P part 2. Okay. Sodium oxide talk about the structure. It's made up of ions held together by strong ionic bonds. A lot of heat is required to overcome the strong ionic bonds. And now we go to carbon dioxide. Carbon dioxide is made up of molecules held together by weak forces of attraction between molecules. Okay. And because of that, the weak forces between molecules are easily overcome. Between molecules. And this is the answer for November 2014, question 8b, parts 1 and 2.